graphing parent functions and transformations. Parent functions are the core representation of a function. There's no additional numbers or symbols or anything. It's just really like the core function. Transformations are changes to that parent function. When we look at them in a graph, they could go up, down, left, right. They could be stretched, they could be compressed, or they could be reflected. We have 5 parent functions that we're going to focus on right now. The first one is our linear function. It's just y is equal to x. So this is in what you recognize as slope-intercept form. You know there's the 1 in front of the x and the plus 0. So this is always going to start at our origin. We're going to go up 1, over 1, and we can connect. And here is the most basic graph of a linear function. Our second type of function is a quadratic. So a quadratic function, y is equal to x squared. There's some really key values here. They are always, the parent function always starts at 0, 0. It is symmetric on the y-axis. So it's symmetric to the y-axis. And we're going to find some numbers. So if we plug in 1 and we square it, we get 1, 1. If we plug in 2, go over 2, we're going to go up 4. And 3 squared is going to give us 9. Those 3 values are going to be reflected across the y-axis. So once we have one side, we can just match to the other side of our function. And then we're going to create that parabola shape. How do we do this side? Should be a pretty smooth curve. Okay, so there's your parent function of the quadratic. We also have an absolute value. Our absolute value is also going to start at the origin. If we plug in 1, the absolute value of 1 is 1, the absolute value of 2 is 2, the absolute value of 3 is 3, 4, 5, etc. And just like our quadratic, the absolute value is symmetric to that y-axis. So we can do one side and then we can do the other. I forgot to label this one. This is absolute value. Okay. Our next parent function is our cubic function. So again, if we plug in some numbers, and you can also look at your table of values on your calculator, we will also have 0, 0. If we plug in 1, 1 to the third power is also 1. Now 2 to the third power is going to be 8, so we're going to have 2, 8. And this function is symmetric across the origin. So we have at -1, -1, and then -2, -8. We're going to connect those together kind of with this curved line. Come through here, and then go down. Got a little squiggly at the end, sorry. Let me try that again. So we're going to come down. Much better. I don't know, I'm having a really hard time doing it on this graph. Let me zoom out. That's the best one so far, so we'll leave it. All right, and then our last parent function here that we're going to talk about is the radical. So y is equal to square root of x. Again, we're going to start at that origin. If I plug in 0, I get out 0. If I plug in 1, I get out 1. If I plug in 2, I get the square root of 2, which is hard to graph. So I'm going to go to the square root of 4 because I know 4 will give me 2. I also know the square root of 9 will give me 3. So I'm choosing numbers in my domain that are giving me whole numbers in my range when I graph that parent function. And there's my parent function of the radical. Now, all of these graphs can be changed by transformations. So there's a couple different ways to transform a function. One way is to multiply by a number in front of the entire function. So when we do that, that either stretches or compresses our graph, making it taller or shorter, or it can reflect across the x-axis if that a is negative. So our a value will stretch our graph if it's bigger than 1. It will compress the graph if it's between 0 and 1. And if a is negative, it will reflect across the x-axis. The second number that we can see here is our h value. Our h value is always located inside the parent function. So you can see it's inside the parentheses here. Here it's in the absolute value. It's inside the parentheses and it's underneath that radical. When you have an h value, your h value is going to shift your graph left or right. So it's going to shift if h is positive, it's going to shift to the left. And if h is negative, then it's going to shift to the right. The last value that we have is k. And notice k is outside of our parent function. It's not contained underneath like the h. And the k value will move our function up if it's positive. And it will move the function down if k is negative. Those numbers, a, h, and k, they all affect the parent functions the same. So if the h value inside an absolute value is 3, or if it's inside of cubic, either way, that's going to shift the parent function to the left 3. If it was a negative 3, it would shift it to the right. So it doesn't matter about what the parent function is. It matters to look at that value and how the value is affecting the graph.